Hi everyone, this is the walkthrough for the January 7th gas. It's called the Chocolate Teapots by Bill. And we have normal Sudoku rules, 1 to 9 in each row column and 3 by 3 box. Additionally, we have pencil marks in some of the cells. And those pencil marks tell us what the possible candidates are for those cells. So in this cell, we can only place a 1 or a 3. Can't place a because it's not pencil mark. So those are the rules. And before we start on the puzzle, I'm just going to show an example of what a chocolate teapot is, in case you've never heard of it before, or if you've heard the expression but don't know what it is. This is an example of a chocolate teapot. So what we have is 3 digits in 3 cells, such that each cell contains a different pair of digits. So the most common way you're going to see something like this, I set up an example here. In this box, we only have 7, 8, 9 left to place. So I'm going to pencil mark them there, but notice down here, we have a 7 in column 1, an 8 in column 2, and a 9 in column 3. And so we're left with this chocolate teapot triple. And we're also left with 1 down here. This can be 5 or 6, this can be 4 or 6, this can be 4 or 5. Now, the reason they're called that is they're useless in the sense that knowing these 3 cells were limited to 7, 8, 9, even with some given digits down here, didn't actually place a digit. It just left us with this triple. Compare over here, we're left with 4, 5, 6 in box 3, but here we have 2 givens looking at that cell. So that is a 6. And then we're just left with a pair. So that's kind of the difference between a chocolate teapot triple and a situation where you have 2 givens looking at the same cell and just placing it. You get a naked single here and a naked pair. Anyway, these are an example of a naked triple. So by naked triple, I mean we have 3 digits in 3 cells, and those cells can only contain those. They can't contain. So what that tells us is 1, 2, and 3 are in these cells in some order. We could have 1, 2, 3, or we could have 3, 2, 1. But either way, all 3 of those digits are here. They're not here. So this is not a 2. That gives us a 4 there. And that 4 is going to resolve this chocolate teapot. So we get 1 here, 2 here. We also get 8 here, and 5, and 2, and 6, and 8. And once we've resolved one of them, it's just going to feed all the way around. But just to unwind for a second. Notice Bill set up the same thing here. We have 5, 6, 7 here. They have to go in these 3 cells because they're the only digits that can go in those cells. So this is not a 6. We have 5, 6, 8 here. We have 5, 7, 8 here. 6, 7, 8. 1, 2, 4. 1, 3, 4. 2, 3, 4. All works in the same way. We even have them in these locations. So once we resolve one digit, we can fill in a lot of stuff. So this is an 8, 5, 2. The 5 places 6 and 8 here. The 5 makes that a 7, 8, 5. And the 1 here makes this a 3, 4, 1. The 5 gives 9 and 8. Now we keep going over here. The 4 here gives us 2, 3, 4. The 8 gives us 6, 7, 8. We get 4 and 7. And then the 3 gives 1, 2, 3 in that order. The 6 gives us a 5, 7, and 6, and 9, and 5. And that completes all of the pencils. So those chocolate teapots, because there were so many of them, and because they were looking at other chocolate teapots, they were very useful. So now we just have classic finish. And up here I can see we can't have 3 in those cells, so we've got a 3 in one of those, 3 in these. Here, we can't place a 9, so the 9 in this box has to go here. It's going to leave us with 2, 5, 6. And we don't have a chocolate teapot here because we have 5 and 6. So that's our 2, left with a 5, 6 pair. But in this column, 5 can't go in these 2 cells, so it has to go here. Resolve that triple. This is going to be 6, 7. See anything there yet? Okay, 1 and 8 in this box can't go in these 2 cells. So these are 1 and 8. In fact, there's an 8 here. So this is 8, 1. Now we need 5 and 9. We have a 5 here. These are 6 and 7. We have a 7 looking down. These are 2 and 4. These are 1 and 3. The 9, just like down here, is looking into those cells. So we're left with 4, 7, 8. And this time we have 2 in each column, because we've already resolved 4, 7, 8 in 2 different rows. So just fill in the missing digit. Here we have 5 and 6 with a 5 here. We have 1 and 2 with a 2. This is a 3, 9 pair. Now 5 is looking over here, so it's not in these cells. There's also 5 there, so 5, 3. And then these are 7 and 9 with a 7 here. We have 6 and 8 with an 8 looking up. We have 1 and 4. We have 2 and 3. These are 3 and 1. Can't resolve yet. These are 4 and 9, which we can. That's 9, 4. And we resolve anything else. I don't see anything yet. So now we're going to look in the central box and see what place. So we have 4 5s looking into the central box. The only place for 5 in this box is here. We actually have a quad here. Notice that. 1, 2, 3, 4. So this is kind of the chocolate teapot quad in some sense, but it is very useful here. It means the only digits we have left in the column are 6 and 9. So this is a 9, this is a 6. That results 3 and 9. These now are 4 and 7. 7. And that 4 is going to come down here. 2, 4. 1, 4. The 1 is going to place 3, 1 and 2, 3. 6 here goes 7, 6. We have 3, 8. The 3 places 1 and 3, and then 1 and 2 to finish off. And that's how you solve the chocolate teapots.